Now, just like when we do u substitution integration, you have to change your u's back to x's. When we do trig sub, we have to change from theta back to x as well. So I want to show you an example of how we do that. So in an example 2, let's suppose that we made the following substitution. We have 2x is equal to 3 sine of x. All right. And let's say that after doing our integration with respect to theta, we end up with theta minus natural log of the absolute value of secant theta plus tangent theta plus c. We want to now take this answer and write it back, change it back to being in terms of x. So how are we going to do that? Well, the first thing we should do is let's isolate the sine of theta. So if I divide both sides by 3, I'm going to get sine of theta is going to be equal to 2x divided by 3. Okay. And at this point, I want to remind you of some basic trigonometry. You know, in trig, we learn about something called SOHCAHTOA. And what this means is the SO part is sine is equal to the opposite over the hypotenuse. Cosine is the adjacent over the hypotenuse, and tangent is the opposite over the adjacent. So what we want to do is we want to draw a triangle, a right triangle. So let me draw my right triangle over here like this. I'm going to put the little square in the corner to indicate it's a right triangle. And I'm going to put my theta in one of the non-right triangle corners. And what we can see is that because I have sine, they're telling us basically that the 2x is the opposite side and the 3 is going to be the hypotenuse. So I'm going to come to my right triangle. I'm going to put a 2x where the opposite side of theta is, and I'm going to put the 3 where the hypotenuse of my right triangle is. And then what I could do is I could use the Pythagorean theorem to calculate what the third side here is. So that should be the hypotenuse squared, which is 3 squared, which is 9, minus the opposite side squared, which is 2x squared, which would give us 4x squared like this. So just to be perfectly clear, the opposite side is 2x, the hypotenuse is 3, and the adjacent side of our triangle is square root of 9 minus 4x squared. So now when I go to really write, you know, I'm trying to take my answer, which I'm highlighting in yellow here, and I'm going to translate that back to x. How am I going to do that? Well, to isolate the theta, we need to take arcsine of both sides over here. So our theta is going to be equal to arcsine of 2x minus 3. And now when I translate that highlighted yellow part, my theta minus natural log of absolute value of secant of theta plus tangent of theta plus c, and that's going to become, we're going to have the theta is arcsine of 2x over 3. We're going to have minus natural log of the absolute value of secant theta. Now secant theta is 1 over cosine theta, which means that secant theta should be equal to the hypotenuse over the adjacent side. So our hypotenuse is 3, and our adjacent side is the square root of 9 minus 4x squared. So that's the first part. And we want to add what we get when we take tangent of theta. Now tangent theta is the opposite over the adjacent. So the opposite side is going to be 2x, and the adjacent side is going to be square root of 9 minus 4x squared. We close off that absolute value, we tack on a plus c. Okay. So I hope you all can see that we've basically switched from theta back to x by using right triangle trigonometry and the Pythagorean theorem. All right, everybody, take care.